Let's talk about inverse functions. Before we begin, let's talk about a few definitions. Let's begin talking about relations. A relation is any set of ordered pairs. The set of all the first components is called the domain, and the set of all the second components is called the range. A relation in which each member of the domain corresponds to exactly one member of the range is a function. And one more definition. The definition of the inverse of a function tells us that the domain of f is equal to the range of f inverse, and vice versa. This means that if the function f is a set of ordered pairs x, y, then the inverse of f is a set of ordered pairs y, x. Let's get started. Find the inverse of a given relation and determine whether the inverse is a function. I have the relation 3, 2, 4, 1, and -1, 5. The inverse is 2, 3, 1, 4, and 5, -1. Since every value of x has a unique value of y, the inverse of this relation is a function. I have the relation 1, -5, 2, 7, 3, 2, and 10, 2. The inverse is -5, 1, 7, 2, 2, 3, and 2, 10. Look at my domain. In this inverse relation, there are two different values of y when x is equal to 2. The inverse of the relation is not a function. Let's study these functions. I have f of x, and I also have f inverse of x. Be careful, this -1 is not an exponent. This is read f inverse of x. Let's plug in some values for the domains of each of these functions and find their range. We will begin with f of x. Let's plug in 0 for x, the domain. When I plug in 0, 3 times 0 is 0, minus 2 will be -2. Plug in 2, 3 times 2 is 6, minus 2 is 4. And I will continue plugging these in and getting values for my range. Let's do the same for f inverse of x. F inverse of x is x plus 2 divided by 3. If I plug in -2 for my domain, I will get 0 over 3, which is simply 0. If I plug in 4, 4 plus 2 is 6, divided by 3 is 2. When I plug in -11, in the numerator I will get -9, divide that by 3, and that will be -3. And I will plug in -5 for my domain, for my x, and I will get -1 for my range, or my y. Notice the ordered pairs of the function and its inverse. I have the ordered pair 0, -2. The inverse has a point -2, 0. The point 2, 4 is an ordered pair on the function. The point 4, 2 is an ordered pair on the inverse function. Also notice that the domain of the function is the range of the inverse of that function. And the range of the function is the domain of the inverse of that function. We can also find the inverse of the function. We will replace the f of x by y. We will interchange the x and y. We will swap them, just like we noticed in the previous example. All of the domain and range will be swapped. And then we will solve for y. And so this is our new y. So instead of f of x, this is our f inverse of x. Let's get to work. I have the function f of x is equal to 3x minus 2. I will replace the f of x with y. And now I'm going to swap the x and y. I am swapping my domain and my range. So I will have x is equal to 3y minus 2. I will now solve for y. I will add 2 to both sides. I will then divide by 3. I have now solved for y, or this is my new y. This is f inverse of x. So f inverse of x is equal to x plus 2 divided by 3. Let's study this function and its inverse a little more. This is my function, and this is my inverse function. Let's notice some points on here. The x and y's are swapped. Another thing you will discover is that the function and their inverses reflect over the line y is equal to x. We will study more about inverse functions and their graphs in the next video.